Yes. Um, good, good evening, everyone. My name is Eric Peter Oyagala. I'll be taking you through my final semester data visualization coursework. Now, this coursework is about water quality, and here sharing is my the type of data that we're using. So we're provided with an Excel file with several sheets that have sort of data, water quality data for every district. So every sheet represents a district. Now, to go through a sample, some of the columns of the data, we have sort of the source of the of the water, things like well, borehole, spring, and so on and so forth. But all this is represented by village, parish, sub-county, and to the district level. Then we have some water quality data points like electricity conductivity, pH, stability, color, and also things like total alkalinity of the data and things like nitrates. And some of the columns vary from one sheet to another. There are districts that didn't have some of these data parameters that were appearing in another sheet. Now, this data was processed. We wrote a script to sort of organize this data to a more organized format that we're loading in using D3. So to share is the dashboard that was required. That was a requirement for this particular coursework. Now, here I'm presenting a couple of visualization to try and make sense out of this data, and one of them is the number of water samples per district. As you can see here, we sort of created a color legend that simply provides how the variations of the data points are varying between districts, and we realize that the one in yellow orange shows that the Lamont district had more data points compared to the other districts. And so we are presenting this according to sort of the number of water sources available in that district. Hence to sort of provide, to show that, okay, there is a high water availability in these regions. And as we can see, Mubende and Gugweri have sort of a lower water source availability. Now, beyond that, we look at a spatial distribution of water quality. This is, we plot the locations or the villages to sort of look at the parameters that determine the water quality around the regions. So we have green representing good water quality and red rather to represent a very low water quality. Now, to start with, we look at sort of electrical conductivity. We realize that most of the data, the water sources are very, they have a high electrical conductivity. And we see that some of the regions are in sort of the central region, but also in deeper areas of the distribution of the data. And then just to look at some of the things that are really important here is, for example, when we look at the total dissolved salts in the water, we see that areas of probably areas in Kayunga, areas in Nakasongola have, a high rate of dissolved salts in the water, and we show this using the bubbles on the Ugandan map. Then, of course, we realize that during the pre-processing of the data, just to note that some of the data that was provided, we had eastings and northings, and some of the data points were missing the GPS coordinates, and that's why some of them we automatically generated has to have some outliers in this particular case. Now, to move forward, we sort of try to pre-process the data and see that we have an informed sense of the water sources. So we realize that we plot that using a donut pie chart that helps us to understand that one of the highly available water source is the boreholes in the regions plotted on the map. For example, when you look at here in Kamuli, in regions of Bugweri, we realize that there are so many boreholes being used as the water sources in this particular case. Hence, of course, there is also other sources, but also we recognize the availability of wells and this particular sense also. Now, to sort of look at the distribution of the parameters of water quality between amongst the water sources that are represented in this case, we try to sort of plot a stacked bar chart that traces a bar race chart that helps us to understand that in the sense most of the data has a lot of dissolved salts. For example, we see the tap water has a lot of dissolved salts parameters, but also we have to recognize that most of this data can conduct electricity. So it is highly conductive when you look at the color map key here, and that we are able to understand into the source level of sort of the data and so on and so forth. Now, to sort of get a sense of the pH of the data on the village level per district, we added sort of a filter here that will help us look at the pH, the water pH at district level, and realize that a district like Lamu has a high pH in the water. So we are using sort of a candlestick chart to sort of look at the rates of the pH for this on the level on the village level per district. This helps us to understand that some in areas with again in areas with total sort of in areas with high pH, probably the water is sort of is of good quality according to the visualization on the Ugandan map. Yeah, so this gives us a sense to look at how we can visualize water quality in the regions of the country, and hence helping the decision makers on which areas to actually look at in which kinds of water sources to improve, or which kind of water sources to add that's more available to people depending on where they live. So that's it on water quality data visualization. The link is posted below the YouTube channel. You can check out the visualization. Thank you.